Hello, future elementary educators. Let's talk about similarity. Let's talk about what we mean when we say that two figures are similar. So what does it mean to say that two figures are similar? We mean that the angles of the one figure are congruent to the angles of the other figure. If this angle is congruent to that one, if this angle is congruent to that one, and if this angle is congruent to that one, then we say that the two figures are similar. In the vernacular, if we were to talk about similarity, we could argue that we have the same shape, but one is bigger than the other. It's the same shape, but one is an enlargement of the other, or one is a shrink of the other. Uh, that's what we mean when we talk about similarity. All the angles of one figure are congruent to all the angles of the other figure, and if that happens, the figures are similar. There are a few ways for us to know that figures are similar. One way is what we call angle-angle similarity, which feels like it makes sense. This angle and this angle congruent to this angle and this angle. You should pause the video to think about why that's enough information. Well, that's enough information because, did you pause? Because if we know what this angle is and what this angle is, we know what that angle is. And if we know what this angle is and what this angle is, we know what that angle is. And they have to match because we know the angles of a triangle have degree measures that add up to 180. And so if we have two angles, that's enough to argue that the triangles are similar. There's another way we talk about similarity, and it's called side angle side similarity. Well, what does that mean? Well, that means that we know information about two sides and we know information about the angle between them. So we have some angle that's congruent in both, but then we know that the sides are in proportion. What does that mean? That means whatever this number is here and whatever this number is here, these are some multiple, the same multiple of those. So maybe k is 2, and maybe k is 5, and maybe k is 1.5, and maybe k is 0.4, and it doesn't matter. As long as these are in proportion with those, the sides that contain this angle are some multiple of the sides that contain the congruent angle over here. We say that the triangles are similar. So when we do side angle side congruence, these two sides have to be exactly the same measure as these two sides. When we talk about side angle side similarity, it's enough to say that they are in proportion. And then there's a third way we talk about similarity, and that's what we call side angle side similarity. So that's useful if we don't know anything about the angles. We just know about the sides. And again, the key is that the sides are in proportion. So whatever this is, whatever this is, whatever this is a multiple, this is the same multiple, this is the same multiple. If you can get the side lengths of one triangle by multiplying the side lengths of the other triangle by some fixed number, then we say that the sides are in proportion, and if all the sides are in proportion, then the angles have to be congruent and the triangles are similar. In a further geometry course, we would prove this in a more rigorous way. For what we're looking to do with young people, we can just talk about things being in proportion, and that's enough for the young people. Okay, so the other piece that's left for us to talk about are proportions. That'll be another screencast. In the meanwhile, let's imagine, shall we, that the triangles are similar. And then let's imagine that the triangles are similar. Let's see, that'll be 60 degrees, and that'll be 10, and that'll be 12. That'll be 60 degrees, and this will be 20, and we want to know that. Let's imagine that this is 5, and this is 12, and this is 13, and then let's imagine that this is 15, and we want to know what those are. Pause for a moment, make sure that you can find the other sides, the other angles if you can. Hit the pause button, see if you can identify some missing quantities. So I hope what you were able to figure out is that the triangle on the right has sides that are 3 times as big as the triangle on the left, because 15 is 3 times 5. So we multiply the other 2 sides by 3, and that's good enough. Notice all the angles here are congruent to all the angles here. And then here we thought that the triangles were similar, and sure enough, this is doubled, so this has to be doubled. Notice that the angle does not get doubled. The angle is exactly the same in those scenarios. Okay, next up, we'll figure out what proportions are all about.